The analysis of microscopic structure is no substitute for the explanation of macroscopic history. On the contrary, the former can be understood only in the light of the latter. And the elusive final unification of theory is a fool's errand if we advance it only by putting ideas that analyze how the forces and phenomena of nature work in place of theories that explain how they came to be what they are. Such is the view of the past and prospects of physics that the argument of this book suggests, and from it, which it draws encouragement. The argument and natural history. The history of our thinking about these issues has always suffered the influence of a prejudice about the hierarchy of the sciences and the exemplary practice of scientific method. According to this prejudice, physics, especially as represented by Newton's mechanics, is the supreme practice of science. Biology is a kind of weak physics. Weak in the relative generality and simplicity of its law-like propositional claims. Historical and social analysis is, by the same token and in a similar sense, a kind of weak biology. The prejudice lives in a form independent of any strict ontological reductionism. It need not require us to believe that all significant explanations at one level can be readily translated into explanations at the supposedly deeper or more fundamental level. All it demands is a view of what scientific explanation should aspire to be at the height of its ambition. The experience of the life and earth sciences or more broadly of natural history shows that the abandonment of the ideas that the argument of this book opposes need not compromise the practice of scientific inquiry. Poincaré believed the idea of immutable laws of nature to be an indispensable presupposition of natural science. The working assumptions of many physicists and cosmologists go much further. They embrace the two cosmological fallacies, as well as the presupposition about nature and mathematics underlying those fallacies. They embrace the fallacies and their presuppositions not just as contestable scientific theories or philosophical doctrines, but as a necessary requirements of science. The development of life and earth sciences since the 18th century shows the opposite. Science can survive the overthrow of ideas against which we here rebel. If it can survive their overthrow in natural history, it can also survive it in cosmology and physics. The claim that biology must use explanations different from those deployed by physics has often been associated in the history of ideas with vitalism. The idea that life is not only an emergent phenomenon, but also a radical novelty. According to this view, living beings conform to regularities entirely distinct from those that operate in lifeless nature. Thus, the life sciences would be safe in a clearly circumscribed domain of their own, neither subordinate to physics nor threatening its entrenched practices and established self-conception. Nothing in the argument of the next few pages relies on the thesis of vitalism or on the acceptance of this strategy of peaceful, unthreatening coexistence with the styles of explanation that prevail in physics. The history of the universe witnesses the occasional emergence of new structures, new phenomena, and new forms of life. New forms of change. Such novelties do not begin with the origins of life. The forms of explanation deployed, however crudely and inchotely, by natural history extend backward beyond the life world to lifeless nature, on Earth and in the cosmos. The question of how far back into the history of the universe and how far up into cosmology the value of the way of thinking that we associate with natural history may go remains open and unanswered. Before advancing, it is important to dispose of the confusions engendered by the long-standing controversy about reductionism. In all its versions, strong or weak, reductionism serves the idea that there is a hierarchy of forms of explanation. Physics towers at the top of the rank order. Relative place in this hierarchy conforms to a many-sided standard. How general and fundamental an explanation is. How fully it embodies the explanatory strategies and assumptions of the Newtonian paradigm. And how qualified it is to wed mathematics. At the summit of the hierarchy stands the tradition of physics that Galileo and Newton inaugurated, and that Maxwell, Einstein and Bohr continued. It is the same science whose matchless accomplishments are marred by the two cosmological fallacies. One of the most important standards distinguishing the supposedly more perfect from the seemingly less perfect in this methodological hierarchy is the place of time, of history, and of historical contingency. there are three distinct and connected elements in this alleged descent from the high ground of the most exacting standard of scientific explanation. The first element is the extent to which the subject matter of the discipline is a unique and irreversible process. The second element is the looseness of the connections among the independent causal sequences that make up any real transformation in history. To take a simple example in parentheses, in natural history, the effects of natural selection on speciation are shaped by, among many other factors, the connections and separations of the land masses of the planet. The third element is the diminished measure in which subject matter and explanation lend themselves to mathematical representation. The less powerful the explanation and the less complete the approach to the idea of science, the more the events subject to explanation assume the form of unrepeated and even unrepeatable processes. marred in the accidents of causal sequences, bereft of close causal connection, and recalcitrant to mathematical depiction, and analysis. It's getting progressively more interesting. Roberto Unger is incredibly sharp. How many Brazilian philosophers, thinkers are there? The one I meet upon is extraordinary. Extraordinary. Glad to be alive to read this and hopefully understand. The less powerful the explanation and the less complete the approach to the ideal of science, the more the events subject to explanation assume the form of unrepeated and even unrepeatable processes. Marred in the accidents of causal sequences, bereft of close causal connection, and recalcitrant to mathematical depiction and analysis. Their hierarchical prejudice survives, whether or not one accepts the strongest ontological variants of reductionism. A major ambition of our argument is to interpret what physics and cosmology have already discovered. And to suggest what they might discover once unburdened from the incubus of these connected methodological biases. In the achievement of this goal, it is crucial that the idea of biology as weak physics and of social and historical analysis as weak biology not be replaced by the opposite superstition. The view of physics as weak biology and of biology as weak history. It is also important that the introduction into cosmology and physics of a historical style of explanation not appear to represent a lowering of sights, a retreat from exacting explanatory ambition. If we could only free ourselves from the established superpositions without surrendering to the mirror image, we might suddenly see in a new light the discoveries of physics and cosmology. We might change our understanding of their agenda. We would learn how to seek in one domain inspiration for insight in another. Strong reductionism claims that all truths about nature, including the truths of natural history, can ultimately be stated in the language of the laws of physics. That is to say, of this tradition of physics. Strong reductionism is not a scientific theory. It is a metaphysical program. This program has never even begun to be implemented. Its professed aim is to unify science on the basis of the established model of mathematical physics. Its real role is to insulate this model from attack by presenting it as the gold standard of scientific explanation. The most effective response to strong reductionism is the demonstration of the failure of the scientific practice that it regards as exemplary. To make sense of what cosmology has found out about the universe, i.e., that it has a particular history. To provide such a response to strong reductionism is one of the aims of this book. Weak reductionism recognizes that we are entitled to explanations different from those of basic physics. Alternative styles of explanation allow us to disregard some characteristics of certain phenomena and to focus on others. Thus, for example, with regard to living beings, we may want explanations that address their distinctive attributes, such as the reproduction of genetic invariance by result-sensitive or goal-directed structures formed through independent ontogeny. A more complete and fundamental physical explanation may not be useful because it may fail to be adequately selective. The mistake made by weak reductionism is to suppose in conformity to the same idea of stable hierarchy of scientific explanation that there is a correspondence between domains of nature and the established methods of different sciences. Under such a view, historical explanations, because they enjoy the right selectivity, may have a larger place in biology and geology, but can have only a smaller role in physics and cosmology. For the physicist and the cosmologist, historical reasoning must, according to this point of view, be subordinate to structural analysis. the most effective response to this diluted dogmatism is to show that no such reliable correspondence exists. Biology is not weak physics, and physics is not weak biology. The hierarchical dogma and its inverse. Are preconceptions inhibiting the progress of science? There is as much reason to move forms of explanation established in biology back into geology, and from there into physics and cosmology, as there is to proceed in the opposite direction. Suppose that the universe has a history. As cosmology has taught us, and that nature exists in widely different states. In some of which it fails to present in the form of discrete elements interacting according to fixed laws, distinct from the states of affairs that they govern, as our fragmentary knowledge of history of the universe suggests. Under these assumptions, the question of which styles of explanations are good for which domains is open to an extent much greater than even the weak reductionist is willing to allow. Such is the circumstance in which we find ourselves. It creates the possibility that the styles of explanation that are now characteristics of the life and the earth sciences have a role to play in cosmology. They may even suggest ways to solve what we call the conundrum of the meta-laws. Consider three styles of explanation that have wide-ranging use in natural history. Their use is by no means confined to evolutionary biology or even to biology as a whole. It includes, for example, geology as well. If their application is not limited to life, but extends as well to the study of lifeless objects, we have no good reason to reject out of hand their application in thinking about the universe and its history. Whether and how they apply in a cosmological context is an issue about how nature in fact works. It cannot be settled by a methodological dogma. If we redescribe these styles of explanation as principles, we can call them the principle of path dependence, the principle of mutability of natural kinds, and the principle of the co-evolution of laws and phenomena. I'm going to have to So, very slowly, Roberto Unger goes through the fundamental mistaken identity of knowledge that we sort of misarranged our thinking, and what we perceive to be knowledge is when you really look at it deep down, not knowledge. It is almost the opposite. And that has become the gold standard for every other viewpoint and areas of knowledge and whole extended fields of knowledge, all harking back to physics. This is where it all started. And Roberto Unger, who is not within physics normally, has understood this. And of course, in some ways, it has become easier to understand because in the social science, the yoke of laws has, so to speak, already been cast away. Came from Karl Marx, Engels, and others that enforced the thinking that reality had law-like features, like the overturn of the upper classes, the demise of democracy, and so forth. All those things are taken from the idea of law-likeness in physics, which began much earlier and had a good century and a half, I would say, to sort of ferment and brew a strong brew that then after infused all thinking, and that this is very equal to the closing of the Western mind, or why not the overtake by the West, the left hemisphere. It is necessitated by a development into generalities, but in a very specific way. Generalities that are then showing to the particulars. This is a complex web, and if you're on the outside and just say science, it cannot be understood. Therefore, it is so long run, his explanation. It needs to go in. And the incision with the knife I mentioned before, it needs to be made in the exact right spot. This is just amazing. I say thank you very much. Have a very pleasant morning. Bye-bye.